Fantastic. So yes, so welcome once again. Thanks everyone for joining. We're very happy to have a great presentation today from Professor Boyi. We have a little bit of housekeeping before we start the presentation, and I'll give you a bit of a background before we get started. So Professor Boyi is an assistant professor in industrial and systems engineering at the University of Florida. And he's a former colleague of mine where we worked together as postdoctoral fellows at the Harvard K.H. Chan School of Public Health. And his research interests are in ergonomics, biomechanics, system safety, human motion analysis, a lot of work on machine learning as well that we've done together. So that I know that's also a topic of interest for Dr. Hu. So today, before getting into the keynote presentation, I just wanted a few brief slides giving you some information about TransMedTech Institute. So starting here, this was an institute that was established in 2017, and it's a large ecosystem at the University of Montreal. TransMedTech is really focused on transdisciplinarity and open collaboration, and really has two major aims. On one side, they're helping to develop different medical innovations in the technology space, but at the same time, this dual aim of also helping to train the next generation of students and for medical technology experts, which will be able to support our industry. One of the things that I wanted to highlight today about the TransMedTech Institute is this emphasis on the living lab approach. So for those of you who are unaware of this approach, the idea is that everything that we do is co-developed with all the integrating the interests of all the stakeholders as early as possible in the process. So we think already of the end user as we are developing or even just planning our research or our new technological innovations. And really this helps us to integrate any new innovation into the healthcare system and to ensure that it actually responds to the needs of our users. So this seminar is co-hosted by two professors, myself, Philip Dixon. I'm an assistant professor of biomechanics at the School of Kinesiology and Physical Activity Sciences at University of Montreal. I'm also a member of the Biomedical Engineering Institute and a researcher at the Shu Saint-Justine Hospital. I'm the co-director of the Simulation and Movement Modeling Lab at the University of Montreal. So I just very briefly show three of my research interests related to real-world motion analysis, development of different software that can help for biomechanics community, and of course, a big branch in terms of different machine learning applications that kind of help these two projects. My co-host, Professor Abofazo Mohebi, is an assistant professor of mechanical and biomedical engineering at Polytechnique Montreal. He is also a researcher at Shu Saint-Justine and Technopole in pediatric rehabilitation. And he's the director of the Polytechnic Lab for Assistive and Rehabilitation Technologies, otherwise known as POLAR. And his work is related to assistive and rehabilitation robotics, neuromuscular control and movement analysis, and applied artificial intelligence. So we also have a lot of shared interests. So the program today, we're well underway, our quick introduction that we like to present. And then afterwards, we will hear the main event from Professor Boyi. There'll be a short period of Q&A and potentially some concluding remarks towards the end. So I'll give the screen share over to Professor Hu in just a moment. For the participants, when you're asking questions or even during the presentation, if you feel like having your camera on, that's always pleasant for the presenter. So please go ahead and do that. And I'll allow Boyi to share. So here we go. Thank you very much.
Okay, hello everyone. Nice to meet you. So my name is Boyi, who I'm assistant professor at the University of Florida Department of Industrial and Systems Engineering. So as I believe you can hear, my throat doesn't feel very well today. I will try to speak up, but please bear with me. Okay. So the topic of my talk today is to prevent the following injuries and improve physical mobility using motion analysis and emerging technologies. Okay, so this is the outline of my talk. I will give a brief narrative of my personal research interests, and then I will go over the motivation of a series of studies, and then I will divide my relevant research project into 3 categories: injury prevention, mobility improvement, and biomechanical assessment. Okay. So in brief, my research will shed light on the fundamental changes in the built environment and robotics and Internet of Things, IoT, that are needed for successful integration of emerging technology into the lives of older adults, especially the subgroups with special needs, and including hospitals, nursing homes, or our retirement communities. And the IoT and the robotics technology methods, design and data analysis, machine learning will also be customized to focus on these unique application environments and the targeted user group. So my research always involve broad stakeholders, including practitioners, admins, government agencies, and industry partners. Okay, so today I will present some of my concluded and ongoing projects. And there are a few more that I'm very excited to share, but especially the works with collaborative robots and service robots, but they are still ongoing, and I believe they are not presentable. Okay, so if I will have other opportunities, I will, maybe later time, I will be excited to share. Okay, the motivation of my research, my research in this regard focus on injury prevention. I think most of our audience are domain expert and have some background in knowledge. We know falling is a huge issue, especially for aging population. So based on the data, 1 in 4 adults of age about 65 report falling each year. And I list some other detailed stats. Okay, I think I'll just skip that part. And my research has 2 aims. So try to prevent fall injury from happening using environmental and other interventions, and trying to improve and assist people with special needs after a falling occurred. And methodology speaking, biomechanics assessment is the tool that I utilize during the process. So let's start with the falling prevention. Okay, so the first specific project I'll be talking about is focusing on an external factor, which is the influence of artificial lighting, on retirement community residents, aging residents, their nighttime movement. Okay, the problem we identified by collaborating with a local retirement community is that residents, they have very high risk of falling due to poor lighting at night. Okay, especially for those people with various chronic diseases, mobility or motor control or eye disease, that kind of thing. And it's hard. It's hard for them to mitigate the impact. So one potential solution we come up with and also try to leverage the current smart gadgets and Internet of Things is we try to design and develop a smart destination-based lighting system that can be installed easily and customized to most of the current retirement community units. Okay, and to verify the the prototype, we try to recruit 15 community dwelling adults. All of them were 75 years or above, and there were 6 males and 9 females. And we try to conduct the experiment with the highest fidelity, which means we try to not do this in a laboratory environment. Instead, we went to their residence units and install and customize the lighting system. Okay, so the system itself is easily installable, and we use more wearable motion tracking system, full body motion tracking system to measure and track their motion behavior. And in the next slide, I will describe their specific tasks. And we have some subjective surveys and questionnaires, interviews followed, but this is our scope of this presentation. Okay. So this is a demonstration of the experiment setup. So this part is the lighting system, the LED strip. And so in this particular experiment, okay, we have a specific light intensity and color and everything set up. But right now, the system itself is self-learning. It can learn the preference and pattern of the users and can adjust based on their preference and special needs. And during the test, so participants need to get up from their bed and trying to navigate to the bathroom and do some daily routine and go back in the dark environment. And this is how we set up the sensor system. And okay, next slide. Okay, the gate analysis. So I think I'll just skip this part since I believe most of audience have some background knowledge. Okay, so in brief, when we do the analysis, there are 3 categories of variables. Trunk motion is we try to estimate the balance control and their general descriptive performance, time, speed, cadence, okay, to describe and compare their behavior with and without intervention. And we also measure and analysis the kinematics. Okay, so, and here comes the results part. First, in general, we observe very improved working performance, so which is not surprising. So participants, they showed 11% reduction in working time, and the difference is very significant with their usual nighttime light. So different. Remember, we did this in a highly facility environment. So they have different options. Some of them using their chargers, LED, or other, the moonlight. Okay, compared to their usual night light condition, our destination-based lighting system, first of all, can reduce their working time significantly. Okay, so also based on our analysis, both subjective and objective analysis, participants showed a very, very strong and improved perceptual awareness. Okay, in terms of objective analysis, we identified they showed lower hip flexion and higher ankle flexion. And this trend is consistent with previous relevant work. So which is a good indicator they showed better perceptual awareness. And okay, the third finding is they also had improved walking stability. So which is demonstrated by the smoother trunk motion. And all these results combined shows that the effectiveness of our system. Furthermore, through the questionnaire and interview with them, we confirm the usability of the system. Okay, the system itself doesn't disturb their sleeping pattern at all. Okay, so which is very important in terms of in this regard. Okay, that's summary of findings. So the low and beam lighting is a contributing factor to older adults' abnormal gait and high risk of falling. Okay, so older adults spend less time walking to their destination and their destination-based visual cue compared to normal night lights, and the decrease in working time was accompanied by changes in other working behaviors, including decreased hip flexion, increased ankle flexion, larger trunk acceleration, and smoother trunk lock, motion patterns. Okay, so this is the first published paper in this series. Now, what my team is working on is trying to make the physical prototype smarter and customizable, and trying to integrate machine learning algorithm, and trying to integrate these IoT to the broader IoT network, and trying to integrate this with a home-based smart service robot to make this to improve the usability of the system. Okay, so this is the second project I will be introducing. So is this the problem description? We also identified this problem with the stakeholders together. Okay, so which is residents, they report high risk of falling caused by some busy pattern carpets and walking surface. Okay, so this is some demonstration examples we took from the partnering institutes, and I believe this type of carpets are not unusual in retirement communities, in hospitals, and based on our observation, this can cause huge problems for especially people, aging population. And the solution we try to come up with, leveraging the interior design and building environment modification, is try to add some path-based lighting system as an actual visual cue. Okay, so this is the easy demonstration. Okay, trying to guide their walking path, preferred walking path. And for this experiment, we recruit 32 participants. And okay, so this is the experiment set up. And I'll just try to skip it. And for this intervention, in that experiment, we test the color of the lighting as well as as well as the intensity. Okay, and we have 4 specific conditions. The baseline is without intervention control group, and we also had dim blue, dim white, and bright white. Okay, and for more detailed description, you can find from this published paper. And dependent variables. Okay, I'll just skip that part. So that's very standard gate analysis techniques and parameters. And okay, so this is the very brief narrative of the measurements we included in the in the study. Okay, and this study also include a huge component of subjective measurement, including questionnaires and focus group discussions. Okay, so here's the finding, interesting finding. So against our hypothesis, participants they showed slower walking speed in their blue lighting versus the baseline. Okay, so against our hypothesis, they showed shorter step length in their actual visual cue versus baseline. And they showed increased time of both feet on the ground and their blue lighting. Okay, so our hypothesis was that the light intervention can improve their walking smoothness and making them easier to navigate. And finding number 2 is we observe similar effect using bright white lighting versus control. Okay. And finding number 3 is for people with visual impairment, they had a significant impact in working confidence. So this is a relatively more important finding. So that means the lighting intervention is more important for them. So a significant difference between, especially between the baseline condition and the blue lighting condition. Okay. So in summary, we conclude, the potential reason that the observation was against our hypothesis is this is since a short-term response. Participants, they didn't get used to the actual visual cue, which could actually increase their cognitive mental load as secondary task. And this may need actual training and education in terms of deploy real-world intervention on participants. In addition, participants with visual impairment agreed the visual cues were helpful in maintaining working confidence. Okay, so this is the third project I will be introducing. So, but please bear with me. I think I need to refill my cup and have some water. I'll be back in 1 minute. Okay.
Okay, so just a little pause here from our speaker. So for those of you that may not have joined us right at the beginning, Professor Hu's feeling a little bit sick this morning. He let us know he was having some trouble with his throat, but he still graciously accepted to carry on with the presentation. So he'll be back in just a moment.
Okay, sorry. Let's continue. Okay, so this is the third project along this line. You know, the previous two projects, I think we believe, I believe we did it in late 2020 and early 2021, and paper got published in 2021-ish. And after those earlier projects, we confirm the usefulness of artificial intelligence, artificial lighting on managing the risk of falling for aging population. So we decide we want to do more customized intervention and more elements with artificial intelligence and machine learning. And so the third one is an ongoing project. We try to study the effect of artificial lighting on balance and stability when performing routine evening activities, more than just walking from their bedroom to bathroom. We want to test more. And in addition, based on the first physical prototypes, our group developed some more, another version, another itinerary, another system with stronger and more powerful learning capability. Okay. And let's continue. So for this one, I'll just skip that. Okay, because most of the work are still data, we're still doing the data analysis. Okay, and hopefully you will have the opportunity to read some papers published in the near future. Okay, so the second part of my talk is mobility improvement is somewhat relevant to the first category of research. And in this category, I will try to introduce more advanced technologies I use, include virtual reality, robotics, and other emerging technologies. Okay, so the first project I'll be introducing is repurposing building environment to better fit the special need of people with mobility issues. Okay, the target population is people who have arbitrary disability, which is a huge problem for them. And okay, for these target groups, the problem is we have a very limited of recommendations on affordable home modification. Okay, especially for these relatively confined multi-unit attached homes. And the solution what we come up with is we team up with a group of interior designer and architects. We try to repurpose some of the building environment in layouts to better fit and try to improve the accessibility and mobility of those target group. So the first specific environment we modify was the bedroom. Okay. So on the left-hand side, so this layout is what we found commonly used and recommended by United States Department of Urban and House Development. This layout is the confined and low-cost, affordable living environment. As you can see, the residents, if they need access to the bathroom, they need to have multiple sharp turns and zigzag to the bathroom. Okay, so this is the original design. And by repurposing, we fully demolish, okay, the room, the wall, here and remove the closet. Okay, and we redesign the full environment and make their we remain all the necessary elements, just reorganize and repurpose the environment. So after the modification, so now the residents, they will have very easy access to the bathroom, and this should be very, very helpful, especially for people with mobility issues. People need to utilize other assistive devices. And no doubt, these movable wall need to have strong IoT components to connect and functional to better feed the residents' need. Okay, and we try to evaluate the performance and the function of those design, the repurposed design, by both subjective assessment methods as well as objective evaluation. Okay, so for the objective part, we recruit 6 adults to evaluate the new bedroom design, and all those 4 were able-bodied Asian population, and 2 were people with special disabilities. Okay, so we did this in the middle of 2021, I believe, amid the COVID. So that is, we had a huge difficulty in recruiting participants. Okay, so today's result was based on 6 participants, but now, right now, my team is collecting more data. Instruments-wise, we use virtual reality system. Okay, we build a very representative environment based on the design, and use motion tracking sensors to measure their behavior and to assess the effectiveness of design. So we designed 2 tasks. One is the participants need to relocate a rope to the closet from the bed, represent a daily routine tasks, and they need to try to access, going to the bathroom and return. Okay, so these curve, they show, their working trajectory of the ring design. This is the part they need to hang a rope from the bedroom, and then go to the bathroom. And on the right side is repurposed room. It's a purpose layout. And see, this is where and when they hang the rope, and then they can have very easy access to the bathroom. And okay, so I think the results are quite promising. And another, we did more detailed analysis. So the sequences of actions required for 2 daily activities were very similar between both bedroom layouts. Okay, we did some task analysis, which confirmed the usability of the new design. So the residents, they do not need to fundamentally change their living behavior and preference. And we also put the subtask into 2 categories. Okay, one is more stationary. Okay, the parts that do not involve moving around. Okay, the second category is, they need to translate and move from a place to another. Okay, and the results based on more detailed analysis. You see, this is they hang a rope and go to the bathroom with the original design, and this is the redesigned bedroom setting. participants spend much less time and worked for a shorter distance in redesigned bedroom layout than in the original layout. And this is the task completion time and distance traveled. Okay. Which confirm the objective of the new design has been met. And the motion smoothness when walking to the closet improved in the redesigned bedroom layout compared to the original layout, which is also a very, very positive outcome. Okay, so after we confirm, it seems, the repurposing is a viable and valuable option. We moved another step forward. We redesigned the kitchen environment. Okay, because based on the staff's kitchen, especially for aging population with mobility issue, is the primary location to have unwanted falls. And the left-hand side is a very, very typical original kitchen in the affordable living environment, in the apartment environment. There are many necessary and common, oven, fridge, and a closet, cabinet, etc. Okay, so this is a very, very typical original kitchen, and this is the redesigned kitchen. We tried to work with artificial architectures and interior designers to move around, to optimize the environment, to consider the special needs of people using wheelchairs or with other mobility issues. Okay, we put them closer to a corner, and we design and add a movable and adjustable platform. And okay, participants, the same 6 adults participate, and we use the same technology, virtual reality and motion capture sensors. So task-wise, so we simulate and let participant to use a pan to boil water and retrieve and boil an egg from refrigerator. So which was quite typical task for them. And again, here's the result part. The trajectory on the left-hand side demonstrate what they did in the original kitchen environment, and on the right-hand side is their motion pattern in a redesigned environment. Yeah, so it's very obvious. They showed improved, mobility and accessibility, and with more detailed analysis, participants spend less time in the redesigned kitchen layout than in the original layout, which confirmed by both subjective surveys and objective motion analysis results. They spend reduced time, and especially during the interactions. Okay, you can see the working sections. We observe some changes as well, but not much. The main improvements come from the interaction sections when they need to do some physical work. And this is a detailed analysis. Okay. And I try to add a short video to show you, what the participant will be experiencing in a virtual reality environment. And this is the original kitchen. And okay, and I think ways to have a repurposed kitchen, which better fit the need and the capability of those public groups. And this is the playback of some specific tasks. doing so, for example, putting an egg in the pan, boiling water. And this is the working strategy in each of the testing environments, bedroom and kitchen, both original and repurposed. Okay, and I think after this step, right now we are working on other environments as well, the living room and the public spaces, in the garden, in the hallway. Okay, so the methodology wise, they share the same, very similar pipeline and flow. But as you can see, each environment, each specific environment has its own characteristic and risk factor need to consider. We need to work closely with different stakeholders. Okay, different stakeholders, provide needs, and what we need to work with the interior designers to find a workable, feasible solution that not only work in the lab, but also possibly be accepted by builders, okay, by builders and other stakeholders, retirement community admin teams, owners, okay, which also believe this is a feasible option in the long run. Okay, I think that should be all I have. I will just skip the biomechanics, assessment, which is somewhat technically related to the talk. And the last slide is I want to, acknowledge the host of the seminar, Dr. Phil Dixon, is we did this project together when we did our postdoc at Harvard, and it's quite fun. Okay, and that's all I have for today. So I'm glad. Please, if you have any questions, I'll try my best.
Great, thank you very much, Professor Hu. So we'll take some questions from the audience.
Yes, hi. I have a question.
Yes,
If
go
it's
ahead.
possible. First of all, thank you, Professor Yu, for this presentation. I had a question about fall prevention. From what I've understood, is that lighting would help in diminishing or reducing, I guess, fall, or like diminish the fall risk. But do you have like a percentage or like a number related to that?
Okay, good question. I think my understanding is you want to have more quantifiable results, right? So first of all, falling is a rare event. Without maybe a large-scale longitudinal study, it's very difficult for us to even observe any real falling in those retirement community. So what we do is on the right route, we try to assess and compare their subjective feeling, and also at the same time to use their motion pattern and gait performance as parameters and a method to compare the potential risk of falling. And right now, so what I'm doing right now is we try to deploy and install about 10 to 15 units of those lighting systems in the retirement community, and trying to do a longitudinal study. So maybe the first phase is about 6 months to 9 months to see if it's feasible. And also, the real world engineering is much more complex than laboratory-based simulation. The paper published was just a proof of concept. Right now, we're trying to customize the lighting system. For the retirement community, they have independent living units and assisted living units for different residents who can live independently or who need, special assist. And the layout of their units are completely different, and they have special needs. We need to customize this system, and this will add a new challenge. But apparently different populations, the risk of falling and potential value from the system is different, right? So that I hope I answer your question. We try to add more comparable and quantifiable parameters and results.
Okay.
Yeah.
Okay, thank you very much.
Great, fantastic. If there's any other questions from the audience. Otherwise, I think Professor Mohibi had a question to ask as well.
Yeah, I just don't want to just prolong this presentation of the problems, but I have a very, very small question. It's more regarding the motion capture sensors that you used for the first part of your presentation. So since we're just quite interested in human motion analysis, I was wondering what kind of sensors and what kind of data they would provide.
Okay, so I present about 5 or 6 projects. So in all these projects, we use the variable MUs to track their full body motion kinetics. And depends on different projects, we also used eye tracking devices, eye tracking goggles to track their eye fixation and mental workload. And for some projects, we also measure the primary EMG signals. And I believe that's the primary system we use in our data collection. So right now we've heavily focused on motion pattern, and yeah, and cognitive load is decision making and preference is also focused, but I don't think is highly aligned with the scope of this seminar. So I just try to remove that from the presentation.
And in any sort of way, the data collected from the IMUs or the motion tracking system was connected with a virtual reality avatar or something like that?
Yes. As you can see, especially the repurposing project. So the motion tracking, it's hard to say right now. The motion tracking from the VR goggles need to trigger the avatar motion, right? And anyways, but the variable motion tracking system, the actions signals, we can feed these into the Unity system, environment, and do some customized, trying to develop some, for example, smart, the push door and slide door system. But this is something ongoing. So we are working on that, but right now the results are very preliminary. We have some PCB and schematic design ready and being developed and fabricated, but they are now presentable.
Okay, that's very interesting. Thank you very much, Professor Hu.
Great. Yes. So thank you very much. I think we'll end a few minutes to spare, give Professor Hu a chance to recover his voice. Maybe just a general comment that I would add. I think this has been really fascinating talk for us to hear about the innovations that Professor Hu has been doing, and I think that these real world applications that many of us are trying to do here, we have a great example of getting research out of the lab and actually making it, applying it to real world settings, solving real world problems. So this is really something that I think many of us can aspire to, and it's really interesting to hear that that's the direction that your projects have been going in. So that is fantastic. So I think that is all. Our seminar series will be continuing throughout the summer. We'll make announcements about our next guests in the coming weeks, and we'll keep you all posted. So thank you very much, everyone, for your time. Have a good afternoon. Thank you, everybody. Take care.
Thank you.
Thank you. Bye-bye.